Lodowe krainy w poszukiwaniu ukrytego życia. Join me as we peel back the layers of ice and mystery and contemplate the possibility that life, in its infinite adaptability, may thrive in the most unexpected corners of our solar system.
When we speak of icy moons, we are referring to a fascinating class of natural satellites whose composition is significantly dominated by ice. These extraordinary celestial bodies are predominantly found in the outer solar system, orbiting the gas giants Jupiter, Saturn, Uranus, and Neptune. The immense gravitational fields of these colossal planets play a crucial role in the story of their moons. This internal furnace is key to understanding why these distant icy realms are now considered prime candidates in our search for extraterrestrial life, offering conditions where liquid water, a vital ingredient, might persist. The diversity among icy moons is truly remarkable, ranging from relatively small bodies like Saturn's Enceladus to Jupiter's Ganymede, the largest moon in our solar system. Europa, the fourth largest of Jupiter's many moons, presents a truly captivating spectacle. Its surface is a vast, fractured plain of water ice, crisscrossed by an intricate network of reddish-brown lines and ridges. The evidence for a vast global ocean hidden beneath Europa's icy exterior is compelling and multifaceted. Scientists estimate that this subterranean sea could be up to 100 kilometers deep, lurking beneath an ice crust that might range from a few kilometers to tens of kilometers in thickness. The prospect of such an ecosystem thriving in the inky blackness of Europa's hidden sea fuels our desire to explore this enigmatic world further. Nestled within the majestic rings of Saturn lies Enceladus, a relatively small moon, only about 500 kilometers in diameter. The most spectacular revelation from the Cassini mission was the discovery of enormous plumes, or geysers, erupting from the south polar region of Enceladus. The source of these plumes is believed to be a subsurface ocean of liquid salt water hidden beneath the moon's icy crust. The fact that this material is actively being ejected into space makes Enceladus a uniquely accessible target for future missions. Jupiter, a veritable giant in our solar system, is orbited by a retinue of fascinating moons, and among them, Ganymedes stands supreme. Ganymedes is unique among moons for possessing its own intrinsic magnetic field, a phenomenon usually associated with planets. Data from the Galileo spacecraft and more recently observations from the Hubble Space Telescope studying auroral displays on Ganymedes strongly suggest the presence of a saltwater ocean hidden beneath its icy crust. Further out from Jupiter orbits Callisto, another of the Galilean giants. The upcoming JUICE mission by the European Space Agency is set to study these icy giants in unprecedented detail, promising to shed much more light on the nature of their hidden watery realms and their potential to support life. Saturn's largest moon, Titan, is a world unlike any other in our solar system. The Cassini-Huygens mission unveiled Titan's surface in stunning detail, revealing a world with rivers, lakes, and seas, not of water, but of liquid methane and ethane. Despite this hydrocarbon-dominated surface, Titan is fundamentally an icy moon. Beneath this icy layer and below the surface lakes of methane, scientists believe there is a strong possibility of a global subsurface ocean of liquid water, perhaps mixed with ammonia, which would act as an antifreeze. Titan's complexity, with its thick atmosphere, organic chemistry, and potential for both surface and subsurface liquid environments, makes it an exceptionally compelling target for future astrobiological investigation. Our own planet, Earth, is a testament to the sheer tenacity and adaptability of life. Many of the extreme conditions found on Earth bear a striking resemblance to those hypothesized for the subsurface oceans of icy moons. The fundamental ingredients for life as we know it are liquid water, a source of energy, and the necessary chemical building blocks, often summarized by the acronym CNOPS: carbon, hydrogen, nitrogen, oxygen, phosphorus, and sulfur. The icy moons appear to offer many of these. Yet Earth's own deep-sea vent communities demonstrate that complex ecosystems can flourish in total darkness, powered entirely by chemical energy, offering a beacon of hope for similar discoveries far from home. The Cassini-Huygens mission, a joint endeavor of NASA, ESA, and the Italian Space Agency, revolutionized our understanding of the Saturnian system. Its discoveries at Enceladus, particularly the identification of water-rich plumes erupting from its south pole and the analysis of their composition, were game changers, strongly indicating a subsurface ocean with potentially habitable conditions. NASA's Europa Clipper mission, scheduled to launch in the mid-2020s, is specifically designed to investigate Europa's habitability. Simultaneously, the European Space Agency's JUICE, or Jupiter Icy Moons Explorer mission, launched in 2023, is on its way to the Jovian system. JUICE aims to characterize these moons as planetary objects and potential habitats, exploring their oceans, ice shells, compositions, and activity, providing a holistic view of these fascinating worlds and their potential to harbor life. Mars has long captivated our imagination as a potential abode for life beyond Earth. However, today Mars is a cold, dry desert with a very thin atmosphere, offering little protection from harmful solar and cosmic radiation. In contrast, the icy moons of the outer solar system, such as Europa, Enceladus, and Ganymede, offer a different kind of potential haven. Their most promising feature is the presence of vast, stable bodies of liquid water in their subsurface oceans. The presence of such vast, long-lived aquatic environments protected from surface hazards and potentially energized from within makes a compelling case that these icy worlds could, in some respects, offer more stable and persistently habitable conditions than Mars does today. Our current and upcoming missions, like Europa Clipper and JUICE, are primarily orbiters and flyby spacecraft, designed to characterize these icy moons from a distance, to confirm the existence and nature of their oceans, and to identify regions of greatest interest. The next logical steps in the exploration of these potentially habitable worlds involve getting much closer, ideally by landing on their surfaces, and eventually venturing beneath their icy shells to directly sample their hidden oceans. The technological challenges associated with such endeavors are formidable. Despite these daunting challenges, the scientific payoff would be immeasurable. Future concepts envision not just ice-penetrating cryobots, but also autonomous underwater vehicles, or AUVs, that could explore these dark seas, searching for hydrothermal vents or other signs of biological activity. Our journey through the realm of icy moons has taken us to the very frontiers of exploration, to worlds that are cold and distant, yet shimmer with the profound possibility of harboring life. From the geysers of Enceladus, offering tantalizing samples of its hidden ocean, to the vast, dark seas suspected beneath Europa's fractured ice, and the complex, layered interiors of Ganymede and Titan, these celestial bodies have transformed our understanding of where habitable environments might exist. The quest to explore these enigmatic worlds is more than just a scientific endeavor, it is a deeply human one, driven by an innate curiosity to understand our place in the universe and to seek out companionship among the stars. Each new discovery, each piece of data returned from these remote outposts brings us closer to answering one of humanity's oldest and most fundamental questions. The story of the icy moons is still being written, and you are a part of it.